Jim McGregor here from TIRIAS Research. I'm here with Mario to get a tour, the first tour of the NXP Smart Home Innovation Lab. And this is a kind of follow-on to CES, where they showed off a whole great demo of what the smart home was. So Mario, why don't you tell us a little bit about it?
Great, Jim. Thanks for joining us. We're excited to have you here. This is our smart home lab. It's an area where our engineers can work on solving real problems, either with partners, with customers, or demonstrating our technology. And with that, we're going to walk you through here.
Hey, lounge. Next slide.
So one of the things that we see in the market trends within the smart home, there's many devices. One of the challenges is interoperability, security, as well as mega trends around ML, voice. So what we're doing here is demonstrating our technology and how we solve these problems, whether it's with our connectivity, our security, our MPUs and MCUs.
Hey, lounge. Next slide.
So the team here is going to walk you through some of the challenges that we're trying to solve within the home. It's a complex environment. As I mentioned, there's mega trends around machine learning, AI. We'll show you some examples of that. Security and privacy is a big topic for consumers, and especially in the home. We have some voice technology as well that we've already started to demonstrate here. And really, one of the things that's really coming to head is how do we make the home more efficient and as well as consume less power. So these are the problems that we're trying to solve, either with our customers, our partners, or our teams solving these with our technology.
Now, NXP has a lot of technology, from sensors to microcontrollers, application processors, wireless solutions. Are all these incorporated within the smart home here that we're going to see today?
Absolutely. You'll see some end products. In some cases, you'll see our development boards. But yes, we have demonstrations using our microcontrollers, our microprocessors, our security, as well as our connectivity, as well as all our software that we provide to enable these technologies.
And I'm building a brand new sustainable home, so I get a demo. I get demo units of everything, right?
Absolutely. you get to pick 2 or 3 on the way out. So we do have an experience, so we want to kick off the experience with this. I'm going to hand it over to Avinash, and he's going to walk you through what a typical homeowner will see once the automated home becomes a reality.
Yeah, welcome to the Innovation Lab. And to kick off this experience, we'll showcase a couple of things. One is personalization, so the house knows who you are, where you are, and how it reacts to you. To start off with, I will ask my colleagues, Meghna and Chris Walter, to start this experience. So we'll start off with the home welcoming you. So let's see, have Meghna will require a volunteer here. So Meghna is a volunteer. She is accompanying the homeowner. We're going to step out for a second and we'll close the door.
Yeah.
All right. The homeowner enters the house, and as I enter, the home should react to me. So as you notice, the light comes on, the blinds go up, and the house welcomes me in different languages. So we customize this for the tours that our customers or partners come in, and if you can hear the different languages that the home welcomes you. So that's one.
I'm not hearing the Gen Z. Hey, dude.
Yeah, that's not Avinash's house. That's this team
This
right
guy.
here. Yeah, they're excited. They'll get a little bit more exciting.
Okay. So the next, so the other thing we want to showcase is the dashboard. So the dashboard is basically giving you insights of what's happening in your home. So if you're a homeowner, when you come in, you want to say, hey, what's my next appointment? Or while I was gone, was there anything that I should be concerned about? It could also be something simple as, hey, you are running low on your battery in your smoke detector. Or it could be like, you had some data that was going out and we blocked it off because we thought that the sensor shouldn't access some of the data outside of the house. If you had a water leak, then you would see some of that, and it will automatically react to certain things. So it's more of a informational, giving you information of what's happening in the home, and also helping you, see if there's something that needs your attention. But as it's a smart home, we try to do certain proactive actions. So, like for example, if there's a water leak, it would shut off your wall. So after going to the dashboard, we will show you some true personalization, and that is through how you can use NXP technology to localize and do things around where you are within your location. So for that, I will have Chris and Meghna start off that tour.
Hey there, my name's Chris, and Meghna will be helping me out with this demonstration as well. So as Avinash mentioned, we have this idea of personalization within the home, and this is actually something we kind of showed at CES in the autonomous home. So we have our UWB ultra wideband boards, and I'll actually point you, Jim, over here right behind Avinash. We have one of our anchors here. So this is using NXP's UWB enabled chipset. So we call this our anchors, and we have multiple of these throughout the home. Again, this is an EVK board, so an actual end product would not look like, a random tripod in your home, but for testing purposes, we need to have them all around that's going to be ranging with our mobile phone that Meghna has. So this would be personalized to whoever is in the home, whether it be Meghna, maybe me, Avinash, we could have different personalizations. But the idea of this is we're showing that similar to like a global positioning system, we have something that's more localized within the home. So having, the phone or wearable that you carry around you at all times, the home can know exactly where you are within, each of the rooms here. And with that, we can do some pretty powerful automations, right? So, there's a lot you can do with it, whereas like maybe configuring the lights to turn on, maybe I'm getting home from work, I want certain personalizations if I come through the garage versus if I come through the front entrance here. So now, Meghna's...
And this is the same UWB technology that's being used for exact locations for like automotive applications and stuff like that. So
that's correct.
Very precise positioning capabilities.
Yes, yeah. And we're using, exactly that same technology to, again, get the pinpoint of where you are in the home. So looks like we're good to go. So for this demonstration, we're going to put the home into its demo mode for UWB. So you'll actually see here that the lights will dim throughout the lab, which will be the pathway which Meghna is actually going to walk through here. So as you can see, the lights have kind of all turned off, and you might not be able to pick it up right now, but Meghna is coming from our garage here. So maybe she just got back from work and she's playing music in her car. So now she'll go ahead and enter the home with her mobile phone, right? And the home will recognize that she's entered the lounge area, right? So we see that the lights have come on. You can hear the music blaring. Good choice of music, Meghna. And so she'll go ahead and continue walking, and we can go ahead and follow her as well. And we'll just we're going to be moving toward the kitchen area. So just giving some brief description as we go. So again, Meghna has entered what we call our workbench and common area. So as Mario mentioned, this is a working lab, working engineers. So while we are showing some more finished products, we of course has a variety of projects where engineers are actively working on new devices and new problems to solve within the home. But again, Meghna is going to be moving us over to the kitchen area, which we've now arrived at. And I'll go ahead and end the demonstration mode here so we can continue with our tour. So again, that was an example of Meghna being tracked throughout the home using UWB, which is NXP enabled with her mobile phone, and an example of how you can drive these powerful automations for, just more easily moving throughout your home rather than having to go and turn on or turn off lights, turn on the TVs, get something started on the oven. That can be done for you.
Well, and improve energy efficiency. So, I can even think of safety, to make sure certain things are on or off if you're not in the room, possibly like the stove.
Exactly. And that's a great transition, actually. I'm going to hand you over to Faith here, who's going to talk about our various kitchen appliances.
Thank you. So the first demo in the kitchen is the Safe Cook. Just like you mentioned, safety in the home. So the Safe Cook is one that works on machine learning and uses like presence-based detection. If I come here and it detects my face, the dashboard over there should show that the cooktop is attended. You might be able to see it there. It's that one over there. Just step back a bit. So it should be saying cooktop attended. Nope.
And that would be the
second one from the top.
Second one from the top. There we are, the stove.
was working 5 seconds ago, or working lab. But what the cooktop basically does is when it doesn't detect anyone in the kitchen and the temperature is within a certain threshold, it doesn't turn off the cooktop. But once the temperature exceeds a temperature which is like 600 degrees Fahrenheit, I don't think anyone is ever cooking anything up to 600 degrees Fahrenheit. So once it detects that, it turns off the stove automatically. So now I'm going to simulate that temperature increase to 600 degrees. And so if we look under, it's gone up to 600 degrees and it's going to shut off very soon. Yes. Because the cooktop was unattended. I can do that again if you'd like me to.
Oh, please, so we can actually see it.
Sure.
.72 degrees now.
Yeah, it's not turned on yet.
300.
It's turned on. Yeah. And if we go up to
600.
Yep.
And now it's giving you a message, and now it's shutting down.
Yep. And that's our first safety feature. And the next one we have is in the water leak sensor. We have a water leak dashlight there as well. So this is a water sensor. You can see the electrodes here. And when it detects water, you would ideally put it somewhere where you don't expect water to get to, say, beneath your sink or elsewhere. And once it detects water, it shuts off the valve. So it doesn't just report, but it also makes like active action. So right there, it's going to shut it off. And once I dry this, I'm going to do it again so you can take a video of that if you'd like to. But once I dry this off, the valve should turn back on without me touching the tap at all. There we go.
That's great.
Yeah. And I don't know, as a new adult, I can see how that would help with saving money, especially when it comes to water damages. I can do that again if you want to take a look at the dashlight there.
No, it's okay. We've got the dash.
Okay. All right. And here we have the pantry demo. So we have a pantry classification and pantry detection demo, which is based on machine learning classification and detection. So the one on this board right now is a classification demo. So it classifies these common pantry items. So if we look here right now, the screen is kind of tiny, but it should be detecting tomato sauce. So this item is classified as tomato sauce. And we're currently working on deploying a detection demo on one of our boards as well. That'll be here for Nin.
What about the wine cooler, the beer in the refrigerator? What about all the important stuff here?
That's it. It's in progress. It's in
I have
it's
4
in the
kids in
works.
college. You really think they have food in their house?
And now I can. Do you want me to hand it over to you for the coffee? Yeah.
It's coming here, yeah. This is a coffee machine, but we reconstructed to integrate our voice recognition technologies. Let me show you how to use. Hey XP. Hey XP. Americano. Small. Strong. Start.
Espresso, confirm or cancel.
Confirm. Confirm. This is cook coffee for you. Yeah.
Awesome.
Yeah. And also it will save your face feature inside. Next time you don't need to do these choices.
So everybody in the house has their own personal coffee maker every time they walk up.
Yes. If you just remember, it will remember your selections, and if you're recognized, okay, it will cook coffee for you. Let me show you. Hey XP. Yeah.
Another espresso, confirm or cancel.
Confirm.
That's great. So no actual programming. It's just actually showing what to do the first time, and it memorizes who you are.
Yeah. Yeah.
That's awesome.
Exactly. Yeah.
Which NXP product is in here?
In fact, this for the voice recognitions is VIT technologies, and face recognitions is also NXP IP, software IP.
Now, I have to point out one key point here. Are any of these applications you've shown me so far for the kitchen, do they all have to go to the cloud, or are they all local?
No, they're totally local. Yeah, so you don't need to worry about security.
So
It's just
that's an important feature, not just security, but also internet connectivity. If
Yeah.
you lose that, you've lost your house.
yeah, you're right.
So now this is perfect. This is what I've been interested in. I don't think you should have to have 200 IP addresses in your house. So
Okay.
this is great.
Yeah, that's
Another point,
that's no
Jim. This demonstration is running on our i.MX RT platform.
Okay.
yes, it's not a MPU. I think it's a MCU system.
A real-time MCU system.
Yeah.
Real time.
That's awesome.
Living from the Aku and
So that's I guess Mario, that's a key important point is the we're looking at all these different platforms or using different types of hardware and sensors and everything else. What about operating systems?
So for our operating system, yeah, typically we are running on either FreeRTOS or Zephyr if it's one of our MCU-based platforms. And then if it's one of our i.MX platform, it's either running Linux or Android is what we typically see.
So that's an important point is that this is not just heterogeneous hardware, it's heterogeneous software
Absolutely.
all running together.
All running together, yes.
Okay.
And the demonstrations you'll see, they'll vary depending on the problem we're trying to solve. In some cases, we want really low power applications, so we're focused more on the MCU. Or if we want more performance, then we're using one of our i.MX processors.
And you only have a couple thousand different SKUs, so
Right. It's a whole family of products. I like to call it a franchise of products,
there you
which
go.
many SKUs.
Yes.
So we're gonna step into the living room. We do have another coffee machine example here. One of the use cases we're working on is using ML to analyze the roast of the bean and adjust the recipe of the coffee
Oh wow.
as well. So we're building on the demonstration you just saw and making it a little bit more advanced.
Okay. And impressive. I still want to see the brewmaster, but that's
yeah, we're gonna get to the room.
Kitchen. We're gonna enter the living room and
Yeah.
hand you off to Akshay.
Okay, actually.
So,
Welcome
Jim,
to
you
the living
follow-
room. If you can follow and probably have a seat there on the couch, you'll
Oh,
see
awesome.
the
I get to
lights
sit
turn
down during
on,
a demo. This is
TV
great.
turn on, and the blinds open all automatically. So the living room is able to detect if someone is in the house or not. So it detects and turns everything on for you. Now, if you look around you, you'll see like we have 4 speakers with these NXP chips on them. These are our UWB based anchors and chips. So, and we have a main UWB sensor here. So what's happening here is it's detecting if someone is on the couch and it's sending the location signal and detecting where the speakers are placed in the living room. So some issue with the
So auto audio configuration.
correct, yes.
Awesome.
So the system is able to detect if, let me just be the person on the couch. It's calibrated for me to be right in front of the. Okay, now it detects me. So what's happening here? This is the NXP based audio decoder. It uses NXP's ADA Mini applications processor. So it's sending decoded audio wirelessly over to these speakers. So, and the decoded audio is getting played back if it detects someone on the couch. And if you see a speaker that's in red color, that means the speaker needs some change in its position to auto optimize and make the audio experience much better for the listener.
Well, and if we put a motor on the bottom of that
Perfect.
speaker,
Yeah.
that'd be perfect.
That's work in progress. Also. Yeah.
Assistance here. So right now, the person is not detected. So it's playing the MP3 file inside of the player.
Now, is this also going to automatically adjust the volume according to the user and or the source? Because nothing's worse than having louder music and louder commercials come on the TV.
Right. Because right now it's not programmed to do that. It can be catered to whatever the use cases that it's going to be. So this is just one way to showcase how the UWB is.
That's awesome.
So we wanted to basically just kind of give people the conceptual proof of concept so that people can actually just imagine how the UWB can take
I know for my house, you're going to need a lot more than 4 speakers.
So for that, you may have to go to the 2 rooms down, and you will hopefully see what you're looking for.
Okay. Well, my last house, I think I had something like 40 speakers in it,
40.
inside and outside,
Oh,
and the garage.
Oh,
So the new house, I have no idea how many speakers I'm going to have yet.
but did you have a good way to like play the source in each room, or?
I actually had manual selectors where I could select the rooms, and I had individual volume controls in each room. So it was all manual, unfortunately, because let's face it, you know, all the previous technology sucked. But you know, and were overly expensive. But you know, having this all automated and actually having it identify me when I go from room to room, I'm kind of excited about. I'm very excited about.